Welcome to Hancom office show. I want to talk about heat transfer mechanisms and the first law of thermodynamics. Heat transfer mechanisms. Heat may be transferred from one place to another in three ways: conduction, convection, radiation, direct burning. The first, conduction, is the transfer of heat through a material due to vibration and collision of molecules of the body without actual motion or flow of molecules. Convection is the transfer of heat that takes place due to the actual movement of molecules of the system, like a liquid and gas. Radiation is the way we receive heat energy from the sun. It does not require a medium for its transmission. It can travel through empty space. Here you can check the first law of thermodynamics. Internal energy, U, is the energy associated with the random disordered motion of the microscopic components, atoms, and molecules. The first law of thermodynamics states that the change of internal energy of a system is equal to the sum of the heat flow into the system and work done on the system, change of U, which is equals to Q plus W, where W is minus P change of V. V is a volume and P is a pressure. So the sign convention, a positive W as work is done on the system, minus W, work is done by the system, plus Q, heat flow into the system, and minus Q, heat flow out of the system if the internal energy is become decreased. Worked example 4.6. 2000 joule of heat leaves the system and 2500 joule of work is done on the system. What is the change in internal energy of the system? If the heat leaves, you must express minus 2000 joule plus 250 joule, 2500 joule, which is equal to 500 joule. Worked example 4.7. A thermodynamic system undergoes in a process which is decreased by 500 joule. At the same time, 220 joule of work is done on the system. Find the energy transfer from it by heat. Change of U is equal to Q plus W. Change of U minus W is equal to Q. So minus 500 minus 220, which is equal to minus 720 joule. Worked example 4.8. A gas is compressed at constant pressure of 0.8 atm from 9 liter to 2 liter, and the process 400 joule of energy leaves the gas by heat. What's the change in internal energy? Here is the solution. Change of U, which is equals to, in the process, the energy leaves the gas by heat. So it must be negative. Minus 400 minus 0.8 times 10 to the power of 5 Pascal times 2 times 10 to the power of minus 3 meter cube minus 9 times 10 to the power of minus 3 meter cube. Change of U, which is equal to minus 400 plus 8 times 10 to the power of 4 times 7 times 10 to the power of minus 3, which is equal to 160 joule. The first law of thermodynamics for the thermodynamic processes. Isolated system is a system which does not exchange and no work done. And the cyclic process is the process that returns to its initial state. Isochoric process is take place at constant volume. So, adiabatic process, it's take place without transfer of heat into or out. Isothermal process, it's at constant temperature. Isobaric, it's at